Hi, this is Arun Balaji. We'll have an introduction to the CygNet OSS that provides inventory, service assurance, and service fulfillment functionalities in a single platform for effective management and operations of a multi-vendor, multi-technology, heterogeneous network. In this part of the introduction, we will understand the inventory and service assurance functionalities, followed by a brief demo of those functionalities. Any typical service provider network would be providing various services that are shown in these slides: broadband services through DSLAM or GPON based networks, and PSTN services, and mobility services 2G, 3G, and 4G RANs, and enterprise services. So underlying of these networks, there will be a transport network that comprises of legacy technologies like SDH, EVO SDH, or the new packet technologies like Packet Transport Network PTN, MPLS TP, or Carrier Ethernet network on the access and aggregation layers. And on the core layers, there will be IP MPLS network. And then underlying all these technologies, there will be transport platforms that uses OTN and DWDM technologies. So all these technologies are covered in the application. This slide shows the various functionalities that are covered in the product. The bottommost layer shows the mediation tier, which will contain various adapters that integrate with the vendor network elements, EMS or the NMSS, depending upon the availability of the information in each of those layers, and provide an uniform and an abstract interface towards the application layer. So this layer will take care of abstracting all the differences in terms of the vendor protocols and proprietary protocols and the information models, and provide an uniform interface towards the application layer. The application layer is centered around an inventory. It's a generic inventory framework that is enabled by an auto discovery engine. So the active network inventory is discovered using the discovery and adaptation engine, which integrates with the mediation tier for discovering the physical and the logical inventory from the network. And those inventory are modeled in the active network inventory. And this generic inventory framework can be extended to handle various other inventory like the submarine and the black hole inventory and the passive inventory. The service fulfillment stack contains various functionalities like order orchestration, which takes care of orchestrating the order across various domains, dividing the order into multiple domains for a service that traverses across multiple domains and technologies. The CLR or topology design module provides the path computation functionality for computing the path within each of those domains, and the resource allocation engine takes care of allocating the resources and reserving them for provisioning in the network. And finally, the allocated resource and the path can be provisioned in the network either automatically using the activation engine that will integrate with the mediation tier for provisioning them in the network, or this can be generated as work order, which can be taken offline and manually created in the NMS. The service fulfillment stack integrates with the order management system. So the order management system can be used as a portal for entering the orders, checking the feasibilities, and these orders will directly flow from the order management system into the service fulfillment system. The next stack, which is the service assurance stack, it contains a fault management system which integrates with the mediation and listens to all the alarms that are coming from the network elements. So this provides the basic fault management functionality in terms of integrating all the alarms of all EMS, NMS vendors into a single platform, deduplication of the alarms, and basic alarm correlation, filtering, those functionalities. And then there is a performance management system which is responsible for collecting all the PM parameters and the KPIs from the network and storing them. Over and above these basic fault management and performance management functionalities, the system also provides advanced functionalities in terms of identifying the root causes and the impacts. The RCA or the root cause analysis engine is responsible for computing various root causes like the node isolation or a fiber cut or a card failure or a site isolation. So these are all the root causes that are typically identified by the application. So it uses various domain rules and the operational rules in identifying these root causes. The network impact analysis engine is responsible for identifying the impact of these failures on the network, like what are all the rings that have failed, what are all the various lambdas that have failed, and what are all the nodes that got isolated due to a fiber cut. So the NIA module will provide the impact on the network due to the failures, and the service impact analysis module will provide the impact on the final customers. So who are all the customers who are impacted because of a failure in the network, and what is the level of impact? Like certain services may be completely hard down or service affecting, and certain services may be non-service affecting due to the various protection mechanisms that are available for that services. So the SIA engine will compute the impact on the customer services. So these functionalities provides for efficient service assurance functionality, and then it also integrates with the trouble ticketing system, can integrate with an existing trouble ticketing system that is available in the operator ecosystem like Remedy or ServiceNow, or there is an in-house trouble ticketing system as part of the application, which is an ITIL certified trouble ticketing system. So with respect to access to the application, on the access console front, there is a NOC user portal which will be used, can be used by the NOC team for all the functionalities across inventory, service fulfillment and service assurance, and for the order management and trouble ticketing functionalities. In addition to that, there is a customer self-care portal which can be used by the customers of the operators, so viewing their own services, raising the trouble tickets, for doing a self-care for their services. This slide depicts one of the deployment case studies where inventory and the service assurance functionalities of the applications have been taken. So various technologies that are covered in this deployment are PTN, MPLS-TP, Carrier Ethernet, SDH, EOSDH, OTN, and in OTN there is both ISO at OD or electrical layer and OCH or optical layer, and in DWDM there are 10G, 40G, 100G and 200G wavelengths. So these are all the various vendors that are covered across these various technologies. So Tejas, ECI, Huawei on the SDH front, and Huawei, Ciena, Alcatel, Tel Labs on WDM and OTN, and Cisco, Juniper on the IP/MPLS and Carrier Ethernet along with Alcatel. So the various functionalities that are delivered are auto discovery and inventory, root cause analysis, network impact analysis, SIA on the service assurance front, and the PMS, and service provisioning plus path computation and activation. There is also an operational planning tool which is being used by the planning team for the day-to-day change management activities that are being done in the network. So the metrics of the network, there are around 85,000 network elements and 4 lakh network circuit that is catering to 300,000 customer services.